I think it's exactly. I think it's meters down, and I thought it would be someone. Was very short. Yeah, but I think it was. I don't want to do it. Are you? I don't like it. There's one in Madrid.
They have a little look in Of course.
I see you do it, guys. You look refreshed. I like it.
I feel like
Das Kernteam zu sehen, sind nicht alle dabei sind. Das ein Spiel machen. Jugend Institut. Sorry, das war extrem
I could not have continued.
What did we do in the event?
No, don't worry. Yeah, I mean, I have no idea what
She was late.
Oh my god, I'm so nervous. No, I had to do it today and everyone else I didn't see what
I'm just getting from 7.
I'm heading home.
Exhibit.
I woke up and I wasn't on this. And I realized that I still had I was already kind of awake and then I which is 47. It has been kind of a week. So I actually this is round 2. But thank you. But he's like
everyone, welcome. So I think we're going to start. So this is GY426, week 9. and I'm very happy to be here. It's the first time I'm teaching this class, and in particular this lecture, Climate Change and Inequality, that is a new lecture I'm proposing this year. So hopefully you find it interesting, and I look forward to your feedback. So I'm Ondine Berland. You can call me Ondine if you manage to pronounce my name. If you don't, that's totally fine. I'm a postdoctoral fellow in environmental economics in the GY department. And I have a PhD from University of Paris-Saclay and a master's from Paris School of Economics. My research in terms of methodology is mostly empirical, and I use panel data and structural demand models to study food choices and their associated environmental impacts. So if that's something you're interested in, please don't hesitate to come and have a chat. I'm holding office hours on Tuesdays and Thursdays. And we're going to be together for 3 weeks, so the lectures plus the seminars. So today, climate change and inequality. We are going to see how climate change and inequality are related. On week 10, we'll study climate agreements, trying to understand what makes international cooperation on environmental problems succeed or fail. And on week 11, we'll talk about directed technological change, trying to understand why is green innovation essential for climate mitigation, and how policy can effectively direct technological change beyond carbon pricing, so mostly subsidies towards clean innovations. So today is about climate change and inequalities, and I've structured it in 3 different parts that I consider to be the main 3 types of climate inequalities. The first one is the inequality in contribution to climate change. So basically, we look at the distribution of emissions, and we try to understand who and how who emits and how the emitters differ. The second part will be about inequalities in climate policy incidents. So when policymakers design policies such as taxes, for instance, who is going to be impacted? Are the taxes or policies regressive or progressive? And this really matters crucially for policy design. And finally, inequalities in the incidence of climate damage, trying to understand how climate change affects people, looking at climate damages in particular. So don't hesitate to ask questions and engage during the class. That'd be lovely. So let's start with inequalities in contribution to climate change. So there are basically inequalities in contribution to greenhouse gas emissions. And we are looking at them firsthand because they are the easiest thing to study and to observe in general, despite several methodological challenges that we are going to discuss. It is really crucially important to understand the scale of the analysis when we are talking about inequalities in contribution to climate change. And here what we can have in mind is the between country component and the within country component. And another aspect is also the degree of disaggregation we are talking about, such as whether we talk about the transport sector, if we consider this sector, or looking at the product level. So for instance, people buying different types of cars. There is also the importance of the metric here when we calculate emissions to try to impute it to economic agents. And we are going to see how it's important, how trade matters by looking at and differentiating production and consumption emissions. As well, we'll mention direct emissions and indirect emissions. So most often given that the levels here in terms of knowledge about environmental economics is a bit heterogeneous, I will start slowly with some recaps and then we'll turn to the more technical aspects. So most often we express emissions in CO2 equivalents. the idea is just CO2 equivalents are the mass of greenhouse gases multiplied by the global warming potential of the gas. So for instance, methane, that is widely emitted by beef, for instance, has a greenhouse, has a global warming potential of around 25. Nitrox would have, so N2O would have a much higher global warming potential. And the idea here is that we want to put everything on the same scale, that is CO2 equivalent. So some gas emit way more than others. So let's now look at have a look at an historical perspective, trying to understand how between countries inequalities have evolved over time. And what you can see here on the left panel is that annual greenhouse gas emissions have evolved by world region. And looking at this long-run perspective, we clearly see that greenhouse gas emissions have increased in total, okay? For all the regions in the world, global emissions have been increasing. And then we can see this useful disaggregation by country, seeing how over time different countries have grown in terms of emissions and how there are new players when it comes to emissions, such as since the 60s, China and other Asian countries, for instance. But nevertheless, the emissions of most countries have grown over time. And this is what we see here as well. Sorry if it's a bit small for the ones who are sitting in the back. But this is what we are seeing here, looking at a shorter time span with emissions in 1989 and emissions in 2019. We see that North America, for instance, excluding the US, has grown in terms of emissions, but not as much as China, for instance, that has doubled the amount of emissions it used to be producing. So there are those differences across countries in terms of production-based emissions that we can clearly see by region. And, but what we need to account for is not only the production emissions, so what is produced within national borders, but also consumption-based emissions. And this really points to the role of trade. And when we adjust by consumption, we adjust emissions accounting for consumption-based emissions rather than only production-based emissions, we can see that there is a gap for some countries. And here I'm taking some striking examples that are the United States, the United Kingdom, China, and India. And we can clearly see that first, that there is a gap that has been evolving over time, for instance, for the US, where the curves were overlapping before, so consumption-based and territorial emissions. And with trade opening, we see more of this gap. But also, what we see more interestingly is that territorial emissions are lower for the US and United Kingdom, who are importing countries, and whereas they are higher for China and India, who tend to be more exporting countries. So there are those large differences, and this is something we may want to account for when we think about the distribution of emissions over space. However, obviously, this previous image was hiding the fact that some countries are much larger, so the size of the economies, than others. And what we can see on this graph is what happens when we divide CO2 emissions by the size of the population, getting CO2 emissions per capita. And this is a snapshot for 2024, looking only at production emissions. And what we can see here is that countries that were the biggest the biggest emitters globally, now the ranking has changed after accounting for the size of the population. So for instance, China, who was first ranked, is now third ranked on this figure. And actually, this is just looking at production emissions, so the ranking could even change further if we were to account for consumption emissions. The UK would probably rank higher than China. So this is just to tell you and to point at the importance of accounting properly for the scope of emissions, knowing exactly what we are measuring. And as this, the backstory is clearly the role of trade, consumption habits, etc. Here in this image, we are only looking at per capita emissions, meaning that we have divided total emissions by, from a country by the size of its population. And obviously, it doesn't really provide a snapshot of how those emissions are distributed within a country. And this is quite key because when we try to reduce emissions, so from an environmental policy perspective, we ideally want to understand who is emitting the most, okay? So turning to within country emission is obviously requires more disaggregated data, so it's slightly more challenging. And the idea is how can we emit differences in, how can we estimate differences in emissions within a country? And for instance, by income group, because this is what we want to study to make sure that the policy is not regressive and it's going to be supported by the population and not widen further inequalities. So usually to answer this question, we take a bottom-up approach, meaning that we start from consumption data to then look at a more aggregate picture. And this is what is most often done. So looking at consumption-based emissions by household, which is most often estimated from expenditure surveys. So this is actually the kind of survey that is most widely available across countries. And the challenge is that it can be more or less disaggregated. So sometimes, for instance, in the US, you would have fairly detailed consumption expenditure surveys, but nevertheless, it would be at the product category level, and we don't exactly, if we know that people are eating meat, we don't necessarily know what kind of meat they are eating, and we wouldn't know, for instance, what kind of meat cuts they are eating, which still matters when we want to get the finest picture and the most accurate picture possible of the distribution of emissions. So, any questions so far? No? Okay. Okay. So what we do in general is that we combine those expenditure surveys with estimations of the carbon content of the product, and those estimations, they are also more or less disaggregated, and they are usually at the category of good level. There are two different types of carbon intensity estimates, some that come from environmental multi-regional input-output matrices, where basically scientists follow economic flows throughout the whole economy. So how €1 will evolve throughout the whole economy. And the other approach is a life cycle assessment, which is seen as a bottom-up approach, where in that case, we follow products through the production processes. So for instance, if you look at the case of beef and how much 1 kilo of beef is emitting. On the one hand, in the first approach, you will look at all the euros or dollars monetary units that have been used to produce this kilo of meat. And on the other end, in the life cycle assessment, you will look at different steps of the production processes, trying to understand how much, for instance, land use was necessary to produce this kilo of beef, how much inputs were used, etc., etc. So that's what we have in mind with those two approaches. And basically, we usually combine those estimates either with expenditure surveys, so at the expenditure level, or with surveys that provide information about the quantities, and we are going to see why this matters. So, in general, when we want to study the carbon footprints for product categories, we assume that they are proportional to expenditures. However, this creates two key biases. Does anyone want to explain what those biases could be? I mean, you have them here, but explaining the mechanism rather. Yes.
I think the second one probably refers to the example that you gave before regarding, for instance, the type of meat that you buy. So if you buy either different types of meat, so if it's pork or chicken, it would differ, but also like the type of meat cutness, so depending on what kind of product they buy or the quality that it has, how it was produced, if it's from more ethically sourced or not, it would probably differ in the actual carbon impact of their specific purpose.
Yeah, exactly. And what about the first bias? Yeah.
If the products don't differ in their carbon emissions, but in prices paid, then we also get a skewed estimate.
Yeah. So indeed, if, for instance, and this really matters when we want to account for the distribution of emissions in a population, because richer households, for instance, tend to pay higher prices for the same types of goods sometimes. So if you think of a bottle of wine, for instance, some could pay like 20 euros, pounds, and others would pay like 5, for instance, but still, it doesn't mean that the carbon content inherently differs. However, as you rightfully mentioned with the example of meat cuts, it's actually difficult to know if the production processes matter and to what extent, because for there could be the possibility that the more pricey wine bottle, for instance, is an organic wine bottle where the production is actually more costly, less emitting, etc., etc., favors biodiversity compared to the cheapest bottle. So there's really a question here, and it may sound trivial, but it's actually really important to understand those nuances when we want to precisely describe the distribution of carbon footprints. And we are going to see with the policy examples that actually knowing who emits properly is an important policy question. So this is just, and going back to this idea of what happens when we compare studies that look at carbon footprints from a quantity perspective versus other studies that look at studies from an carbon footprint using expenditure, having this price bias in mind. Actually, something I did do in one of my papers is look at what is the direction of the bias when we compare carbon footprint computed from an expenditure perspective and carbon footprint calculated with a quantity perspective. I compute the ratio here, and I show, so if they were the same, the ratio would be 1, right? And I show that as income, as we progress in the income distribution, so this is the income distribution by decile of the population, we clearly see that the bias increases, so that the ratio increases, meaning that for low-income people, actually, the bias is higher. We underestimate carbon footprint due to the fact, so this is just for food, I should have said before, due to the fact that we don't account for this price effect when we look at carbon footprints from an expenditure perspective. So this is just to show you the magnitude of the error and the fact that the bias will also be correlated with individual or household characteristics if we don't account for those biases, which will then bias the estimation of your result and then bias what we expect from a policy, for instance. So it matters actually quite a lot. Okay. So this leads us to trying to understand how income inequalities varies, how within country inequalities vary, and in terms of carbon footprint. And the most obvious characteristic we have in mind in terms of differentiating households is income. We often refer to this as vertical inequalities, and the idea is to compare emissions across income levels. So here, this is what Hummel has done in the case of the US. So it's a fairly old paper. Nevertheless, I think it's useful because it shows that for starters, looking at a fairly disaggregated income distribution, it shows how that there are large differences in the US population in terms of the distribution of carbon footprint. So the mean is 21 ton CO2 equivalent per year and per person. And we clearly see that households who are in the bottom 25% of the income distribution, they emit half of that, whereas households located in the top 2% of the income distribution, so really the richest individuals, they emit about more than twice this amount. And actually, when we try to understand where we can try to reduce emissions and how do people differ, it's always interesting to look at different types of sectors, of consumption sectors. And here, this is what is being done. And we clearly see that some sectors of consumption are more equal than others. Okay, so almost everyone needs consume gasoline, consumes food and drinks, has emissions associated with shelter. But then the key differences across income groups, they really arise when we look at those other products, other services, and other transport. So the least basic necessities. And here we clearly see that it's where differences arise in the distribution of carbon footprint between low-income people and high-income people. Something that is worth keeping in mind is also that, in general, the consumption of the richest, and so the emissions, therefore, of the richest households tend to be underestimated, for starters, due to misreporting or sampling errors, in the sense that it's very hard to capture what happens at the top 2%, top 1%, etc. Of the income distribution. And misreporting, because some people may also have an interest in not declaring all what they consume and all what they have in terms of resources. Given all of this, and in general, when we look at Gini coefficients and Lorenz curves that tend to capture the dispersion of a certain output, we tend to find that income is more unequally distributed than carbon footprints. Okay, so the Gini coefficient for income tends to be higher than for carbon footprints. And this is, so the curvature of the Lorentz curve is, so the Lorentz curve has a higher curvature for income than for GHG emissions. And this is mostly due to the lack of sufficiently precise carbon estimates, so what we were discussing earlier. Common lifestyle, so the fact that, as we've seen, everyone has everyone emits when they eat, when they live in a house, and when they commute, and the type of the scope. So indeed, when we think about the distribution of carbon footprints, one of the challenges, as we've seen, is to really account for everything that is being polluted at a fine enough grain level. And what often happens is that we only look at consumption-based emissions, but we rarely are able to account for assets. So what people own in terms of income, and those assets, they can be polluting, for instance, stocks, etc. So this is part of the work of Lucas Chancel and Yannick Rem, who have tried to include in carbon footprints emissions that are related both to individual consumption, lifestyle choices, but also financial assets and firms owned by individuals. And they do this work for, sorry, do you have a question? Yeah.
So you said that income is more unequally distributed than carbon footprint, but it's also maybe due to lack of sufficiently precise data on carbon. Would you think that the inequality is biased upwards or downwards? Because maybe richer people tend to have more carbon intense activities, which might not be accounted for. So maybe inequality is actually smaller.
Inequalities would be higher than, no?
Yeah, sorry.
Yeah.
Yeah, but the difference between the carbon inequality.
Yeah, okay, so the difference would be smaller. Yeah, that's a fair point. So going back to this Andre paper where they really discuss the sign of the bias, actually bias number 1, this is what we see here. It's actually higher, so the difference in, so this ratio is smaller, meaning that the bias is higher for low-income individuals, meaning that if we don't account for differences in the price paid, we tend to underestimate the emissions of at the low, in the low part of the income distribution and overestimate emissions for high-income people. So this is more, so this would, in a way, shrink inequalities, right? And on the other end, if there is a lot of heterogeneity in carbon intensities, this could probably further increase the dispersion. For instance, if you only consider the expenditure for the transport sector and you assign one carbon intensity to the transportation sector as a whole, then everyone will more or less have the same. Then you would only account for expenditures, but actually, if you could get a finer grain picture of what people use in terms of transportations, and you can see that some people use private jets compared to others who use a car, then you would have more inequalities in more diversity in emissions, if that makes sense. So I think that it depends on the granularity of the quality effect, so the different types Okay, I'm going to rephrase that because I was really unclear. Sorry. So if you have a very detailed idea of the carbon intensity of different products, you would probably see higher inequalities when it comes to carbon emissions. And if you account for the bias due to this price effect, you would probably see more concentrated distribution of carbon emissions. So it really depends on how you do it. It could also depend on the sector, so it's hard to answer actually. But what is sure, what is certain is that there are some common lifestyles that explain why the income Gini tends to be higher than the carbon footprint Gini. And especially when we don't account for assets, when we just look at consumption, we know that higher income people, after a while, there's some kind of ceiling on consumption, right? Like even if you're really rich, you're not going to consume 10 times more food or 300 times more transport or have, so at some point there's some kind of a cap, whereas for assets, this is much less clear. And we know that the assets of the top, the highest income people, they're really through the roof compared to low income people who have almost no savings. And this is my point with the paper of Lucas Chancel, where they do account for assets and firms. And in that case, when they do this exercise, they find that actually the carbon footprints distribution has a larger span than what was expected with the consumption-only estimates.
A question on that. How do you account for the potential of double counting when you include the firms owned by individuals, because they also produce stuff that is then consumed by other individuals? No?
I think that they do that with the those extended input-output matrices. I think that there's a way of account, because you just follow financial flows. So in theory, there's no double accounting. Personally, I mostly work on food, so I use those life cycle analyses that allow to get the finest grain picture for one sector. But it's true that when you look at the distribution of carbon footprint as a whole across all sectors, then most people use the input-output matrices, because you would be able to have carbon intensities for all of the different sectors, but it's just not very disaggregated. So it also depends on your research question, really. And the level of granularity you need depends on that. But nevertheless, I think that you were right to question the fact that the income Gini and the greenhouse gas Gini are different. And with this Chancel and Rem paper, we would actually expect the curves to be closer, right? At least that it would close the gap. And in the direction of the greenhouse gas emissions being closer to the income distribution than what we usually get when we just look at consumption-only estimates. So actually, it increases the carbon footprint of the top 10% income people by 2 to 2.8, which is really massive. And recently, and they have a new paper looking at global estimates and not only focusing on France, Germany, and the US. If you're interested, I think it's just out. Okay. However, there are not only those vertical differences in carbon footprint, because it's not only a matter of income, but it could also be a matter of within income disparities, socioeconomic differences, so the type of your household, the composition of your household, your education, as well as geographic disparity, which is probably the thing we have in mind right after income is really, but rural and urban households, they do differ. So obviously, they would differ in terms of carbon footprints. And indeed, even though in the lecture on spatial environmental econ, you already discussed with Sefi how that environmental outcomes can differ across locations, I don't think that you tackled the important question of what is causing that. Is it the fact that, for instance, in car-oriented places, people tend to have higher emission because they dislike public transport, or just the fact that they are constrained in terms of the infrastructures? This is something we are going to discuss when we tackle this Lubitsch paper during the seminar. And basically, one of the key figures of the paper is that she shows that the mean household CO2 emissions per year from energy consumption, it's actually quite heterogeneous in terms of locations. We can see that in urban places, people tend to emit less than in suburban and especially in rural places. And this is true with and without controls. So the idea of controlling would be to account for age, gender, race, education, household size, number of children, and homeowner status. So she has super detailed data. And still she finds that even after accounting for all those differences, the light blue bars and the dark blue bars doesn't differ that much. So it's not really a matter of people sorting in different places. So for instance, low-income people who could only be in rural places, etc. It really seems to be a matter of geographic and spatial differences that we're going to tackle this week when we discuss this paper, that I hope you'll enjoy, because I think it's a really cool paper. Yeah.
One short question. Is it because of like necessary consumption that, for example, people in rural places have to travel a little bit farther to their workplace? Or is it because people in rural places like consume more other stuff? Or consume things that are not necessary?
Okay, so, well, it could be both, because in this picture, it's really like energy consumption as a whole. So from your, from transport and housing, and you could see, you could think that commuting, for instance, is essential in your example, but leisure isn't. I think that in this paper, it's mostly commuting, but the main point is really indeed to trying to understand what causes those differences. Is it because people in urban places, they tend to emit more because maybe they have different environmental preferences, different habits, etc.? Or is it because they just have a decent public transport network that allows them not to use their car very much and to have lower emissions? Yeah.
Basically, it can be like the agglomeration effects of living in cities and how like smaller flats, less energy, or like as you said, better commuting routes, better transport.
Exactly.
I just wanted to ask if in the rural case there might be non-separability sometimes between the consumption and the production, because some people might be using some of the energy also for doing the labor for the agricultural output or whatever.
Can you repeat that question?
If the rural one also has a production side to it, not just the consumption, because they use what they consume to produce their agricultural output or whatever they do.
So is this idea related to, for example, some cases where the production and consumption of some individuals is very much interlinked? Like, for instance, the fact that some people emit more because they commute to further away places to work, etc.?
No, I was thinking more on the side of I consume more in my farm to say, use the machines to get all the
So yes, it could be, and this is, so this non-separability assumption is something we see quite a lot in low-income and middle-income countries, right? In that case, I don't think that it would be too much the case, even though it's not impossible that some people would be in this situation. This, like in this specification, it still accounts for the type of job people have. So it would not explain the whole differences. But we are going to discuss that more during the seminar. However, I want to highlight that this is an important topic, mostly because if people, if it's the role of infrastructures that explains those differences, so place-based effect that explains differences in terms of emissions between rural and urban households, then maybe by building more infrastructures, we should be able to reduce emissions, right? If it's rather people's preferences, it could mean that even in rural places, having more more public transportation would not change things. And this is why it matters for our policy to understand those differences. Another type, let me change the slide. Another type of differences we could have in mind. So as I was saying, the first one is vertical differences, so income differences. The second one that comes to mind immediately is perhaps geographic differences. In some of my work, I study other types of differences in terms of characteristics, other dimensions of heterogeneity. And in one of my latest papers, we study gender as a dimension of heterogeneity in carbon footprints. So what we find with my co-author is that there's a 26% in France raw gap in food and transport carbon footprints, with women emitting 26% less than men. Okay? So this is already a big gap, but then, of course, we want to account for socioeconomic differences, because we know that women may not have the same income as men, that we know that men and women don't work in the same activity sectors. So that's what we do. We also account for socioeconomic characteristics, and then we even account for quantities. So the fact that men and women may have to consume different amounts of calories every day for their survival. So these are biological differences that may not explain something going on? Okay. That may explain those differences. And we see that after accounting for differences in socioeconomic and demographic characteristics, there is a gap in carbon footprints that persists. So we move from a 26 raw gap, so an average gap, to an 18% gap between men and women for both sectors, food and transport. And once we account for calories and distances, we find that even after accounting for the fact that men and women may have different constraints and biological needs, there is still a gap that persists, and it's about 9%. So there's a 9% residual gap in carbon footprint that cannot directly be explained by socioeconomic characteristics or quantities. And in terms of policy, this may be less trivial than when we think about infrastructures, obviously. Nevertheless, it could be important to think about, because we show that this is mostly due to the fact that men and women eat different types of goods and consume and buy also different types of cars. So there could be incentives to try to incentivize people to buy different types of cars, or deconstruct the association between masculinity, masculine identity, and eating red meat. Okay, so these are just examples of the within country inequalities we can have in mind. There are many others, and you're welcome to explore them. So The question now is, from a policy perspective, is to understand what matters more. Is it the between inequality or the within inequality component that we want to tackle in order to reduce climate change and have the most effective environmental policy? In this paper from 2022, Lucas Chancel looks at global inequality between 1990 and 2019. And basically what he does is a two-step approach where on the one hand, he obtains country-level greenhouse gases emissions split in three sectors: household, investment, and the government. And in a second step, he distributes emissions to individuals in each country using country-level data on the elasticity of emissions to consumption. So how elastic are emissions to both consumption and income, and for that he uses expenditure survey. The elasticity of emission to wealth, which is the contribution, the main contribution of his paper. So the wealthier you are, how does it affect, what is the marginal effect of one additional unit of wealth on emissions? And he combines this with country-level distribution of income and wealth to try to disentangle the within and between country component when it comes to carbon inequalities. What he shows is that there are large inequalities. So the lowest half of the world population emits 12% of global emissions in 2019. So obviously, if the Lorenz curve was close to the equal distribution, we should have half of the population that emits half of the global emissions, right? So you can already see how distorted this distribution is. And the top decile emits about 50% of total global emissions. Then he looks at the US, and you can compare, so those results are fairly similar to the Hummel paper I was showing to you earlier, where we were looking at the distribution of emissions across income groups in the US. And he shows that to meet the targets of the Paris Agreement, where ideally in the US, each individual should emit 10% of ton of CO2 equivalent per capita, the poorest, so 50% of the population roughly meet the population, those targets, right? And that's what we saw here. So they are not too far from this 10 ton of CO2 equivalent per year. The middle 40% would have to reduce on average emission by 55%, so to halve emissions, which is already quite important. And the richest, so the top 10 decile, would have to reduce emissions by 86%, which is really massive. Then he looks at the distribution of emission growth since 1990 and sees that it's actually quite concentrated at the top of the global distribution. So here, sorry if it's a bit small for the one in the back, but basically you have the global emitter group. So the lowest emitters are here and the highest emitters are here. And you can see that here after 99, so the top percentile, it gets more and more disaggregated, which is one of the key contributions of this group of economists, Chancel, Piketty, etc., to have this disaggregation at the top of the income distribution. And here you have per capita emission growth. And what we can see is that the bottom 50, so it's exactly what I was saying, the bottom 50% is responsible for 16% of total emission growth. And in the bottom 50% of the global income distribution, you have mostly emerging countries, who have seen their emissions rising as they develop. In this bit, you have a degrowth of emissions, which maps this idea of the lower and middle class in rich countries emitting less than before, and this is mostly due to environment policy, standards, improve access to cleaner technology, etc. And in the top of the income distribution, we see that emissions have been growing extremely fast and extremely sharply, with the top 1% being responsible of 23% of emission growth this time. So not only emissions, but emission growth. So they are the top 1%, who seem to be both emitting the most, but also having the fastest trajectory in terms of emission growth. Yes, the first rank and then second.
This is for emissions, not
Yes.
change. Which is because I was thinking it's quite similar to the income one.
It's not too far from the elephant curve indeed.
So it's basically just who gets richer.
I mean, given that in this kind of work, as we were discussing, emissions are proportional to expenditure or income, in a way, yes, you would have fairly similar curves.
Do you happen to know what sort of technologies or what types of consumptions were those strong drivers in the top 1%? Like, did they all of a sudden start flying private jets, or like what's the driver there? Because I think it's quite striking as described.
So I think that it's a matter of indeed transportation, but also I would say it's mostly assets again. I don't think it's super detailed, this bit in the paper, because I was looking at it recently, but he may be discussing it in greater detail. And going back to this idea of what matters most, the between or the within inequality component, well, as we saw in the beginning of this part of the lecture, emissions are rising overall, and they've been growing, and there are like growing differences across countries, as we saw in one of those Our World in Data graphs in the beginning. But it seems that since the year 2000, there's been this inversion where the between country component is decreasing and the within country component has been increasing, has a higher share. Okay? So this is a tail index that measures entropy and allows to do this decomposition between the between and the within component. And what we see here is that within country inequalities now represent the strongest type, the most striking type of inequality when it comes to carbon footprints. Okay. So, in conclusion, for this part, this first part of the lecture, it's important to assess the difference between country and within country inequality. There are methodological choices that strongly affect the conclusion, and that's what we were discussing, right, when comparing the income Gini to the GHG Gini. Today, within country inequalities now dominate between country inequalities. When we'll talk about between country inequalities, it will be also next lecture when we tackle international environmental agreements. But within country inequalities really matters. The contribution to climate change seems to rise with income, but less than proportionally, as we saw. Yes?
Please go.
Oh, okay. There are several other dimensions that matter in terms of heterogeneity, such as location, but also age and gender that we discussed. And those inequalities, they translate into an unequal incidence of climate policy. And that's in part why they matter.
A question again on the within and between country numbers. is that interpreting too much if I think that, or is that because the developing countries have been catching up faster than the developed countries were running away, and so you could interpret that as a success story for development economics, or like does that show that it is working?
Well, there's a lot of evidence showing that growth in emissions goes hand in hand with the growth in GDP. So yes, you could interpret it clearly as a development story. Whether you interpret it as a positive thing or a negative thing, then it's a normative statement.
But also like the rise in within country emissions is also due to the increase of inequality within the developing economies, right? Like because now like there is more concentration between like the top decile of the income distribution. That's why also within emissions have increased compared to between, right?
Yes, it's hard to answer. I think from the Chancel, like just this image we were discussing. Because it depends on where people locate, right? If like there are, in the top 1%, there are people living in developing country and where those assets are, their assets are located, etc. So I think that at least what we can say is that clearly this rise of emerging countries, it comes from, it's very much related to a development story and an industrialization story. But clearly, as you said, it could be hiding a lot in terms of within country inequalities. And we know, we tend to know much less when it comes to within countries inequalities in low and middle income countries as well, because this is a matter of data or research effort, etc. I'm actually starting a paper on carbon footprints in India, so maybe I'll know more in a few years / months. And between countries where there are clear current patterns that are that have evolved or that are quite different from historical ones, with some countries that have developed faster, and this is, as we just discussed, associated with a rise in emissions. Nevertheless, when we compare countries with each other, we want to keep into account what we discussed before, so whether we are talking about production or consumption-based emissions, the type of scale, whether we have divided those emissions per capita, etc., etc. This is quite important, and this is the between countries component. This is something we are going to discuss next week as well, when we talk about climate clubs, etc. Okay, so the second type of link between inequality and climate change that I was mentioning earlier is the inequalities in climate policy incidents. So here the key question is who bears the cost of climate policy? And there is a large expert consensus in terms of the need to put a price on carbon to try to reduce carbon emissions, right? So there was this important survey in 2016 where I think that at least 5 Nobel Prize in economics signed in favor of a carbon tax. However, the key challenge with the carbon tax, and you may already all be aware of it, is that it receives low support, okay, from individuals. So those carbon tax, they can be levied on consumers. So basically, it means that we will increase the cost of consuming the taxed good, and that's what we are going to see today. So for instance, increasing the price of fuel at the pump, or at the producer level, in which case it will increase production costs. But the problem with this kind of policy is that it's very likely to be passed through consumers. So if you increase the cost of producing some cars, the consequence might just be that for the consumer, the cost of buying a car increases, plus it poses problem when you implement taxes at the production level. So for instance, if one were to try to reduce methane emissions by taxing beef, doing so at the production level, the consequence could be that importers would not be affected, etc. So this would pose trade competition problems. Another type of climate policy one can have in mind is command and control regulations. So here, the question we want to have in mind is what is the cost of the regulation and how will it be passed on to consumers? It's something I think you discussed with Sefi. The idea here is that it could be a ban on, for instance, the most emitting types of cars. However, there is really this consensus that carbon taxes are the most effective way to do climate policy, and this is why we are going to study this today. Okay. So I think that we can take like a 2 minutes break, and then we'll turn to the political economy challenge.
He was the lead, right? They often go last time. Oh, German. I'm sorry for the our own campus. What's the school? She's in the it seems like it's more spread out. I think she's one of those like smaller cities.
It's like there's no time to.
It's exactly like Kelly. We see it's a pretty big and
All good? Move this because otherwise.
yeah, but how we're ready is like before actually. You're going there to study what
Along the road. Okay.
Yeah, so much.
Because I guess your studies either less environmental.
There's
one section.
It's actually and like that.
Like
That building blocks.
yeah,
I think was a lecture on
Why naturally?
So banal. Sorry? I was planning your so banal. So we should try it.
Okay, so I think we should start again. And hopefully finish on time. Excuse me? Yeah, let's start again. Okay. So as I was saying, there's a real political economy challenge here, is that there is low acceptance when it comes to taxes, because taxes mean higher expenditure for some people who are already budget constrained. So in general, it doesn't really go well. And it's not only actually a matter of taxes, but it could be also a larger political economy problem where environmental policy doesn't receive a lot of support. And that's what we've seen in France with the Yellow Vest movement in 2018, where people were protesting against the rise in the price of gasoline. But there's been also some protests in the UK with the implementation of ultra-low emission zones, which impose a fee when a car enters London. There are some protests that took place in Canada, where you could think of some contestation movements associated with coal plants closure, etc., etc. So there's really this challenge of how can we make sure that climate policy is better accepted, receives higher support, and this. And initially, economists thought that it would be very much related to climate incidents. So there is this very cool paper from Antoine de Chez-le-Prêtre and co-authors, in which they survey individuals in 20 countries and highlight that there are 3 key predictors of support for a given climate policy. First, its perceived ability to reduce greenhouse gases emissions. So if people think that the policy is going to be effective or not. Second, its perceived distributional impact on lower income households. So people do care about whether inequalities are going to widen or not. And finally, the perceived economic impact on people's own households. So the very direct effect of the tax, of the policy on yourself, or the people living in your household and thus sharing an income with you. Intuitively, this connects to inequality in contribution to climate change, because those emitting the most will a priori be the ones experiencing the highest increase in expenditure. And this is in part why I started with the distribution of carbon emissions. Unless people emitting the most can actually easily substitute towards cleaner technologies. For instance, if richer households who do emit a lot can buy electric vehicles, then they may only be moderately impacted by the tax. So this really relates to this central parameter, that is the elasticity of demand for high carbon goods. So as I was saying, there is this consensus to put a price on carbon. However, there is low support for climate policy. So the central concern is to try to understand if climate policy is regressive, for starters, so in the sense that poor households will carry a larger burden than richer households. And the second thing is, if regressive, are there ways to compensate the ones losing from the policy? The most straightforward way to implement a carbon tax, as I was saying, is to tax directly consumers. So this is what has been done. And some economists have asked themselves, would it be regressive? And if yes, to what extent? To do that, we need to account for the tax burden, but also, as I was saying, how households react. So the elasticity, as some households may be more elastic than others. And this is what Thomas Duen does in a 2020 paper, where he does a micro simulation to assess the distributional impact of a carbon tax in France. So he studies the doubling of a carbon tax and looks at both vertical and horizontal effects. So not only the income, how it affects the income people throughout the income distribution, but also accounts for differences between rural and urban households, which really matters because we are talking here about a tax that affects both transport and housing. And what he finds is that the uncompensated price elasticity of transport and housing energy is actually quite low compared to other non-durable goods. So those goods are inelastic, meaning that when the price increases, people cannot really reduce their consumption of such a good. he also highlights that there is heterogeneity with low income and more rural households being more price elastic when it comes to energy. So those people can actually be more elastic, but this could mean that, for instance, they're going to travel less or they're going to heat their homes less, which can be a problem in terms of welfare impacts. And this is something, actually, I should have said that you've seen with Sefi when you discuss the example of the Danish tax. So this is like the most on CO2, so this is like the most direct effect. If people are inelastic, they will be affected strongly by the tax. But something that you also want to account for when you do such such analysis is the second order welfare effect, where you want to account for the elasticity of household demand given changes in prices. So the intuition here is that if lower income and less urban households are more energy constrained, we should, what they are doing in terms of elasticity is to have a stronger response to price increases in order to soften the budget constraints, so to limit the effect of the tax on the budget constraint. So we can see low income and rural households reacting more than richer households. And what he's saying is that despite this second order effect where people after the tax to try to limit the effect of the tax on their budget constraint adjust their behavior, it is not sufficient to cancel the regressivity of the tax. So nevertheless, low-income people, households in that case, are going to be more affected than higher-income households. So he goes on, and I'm not going to expand too much on that, by computing the effort rate and trying different types of measures to really understand whether the tax is going to be regressive or not. And what he finds is that the additional tax on disposable income, so the effect of the tax for different income groups, for different types of households, is actually much higher when you look at income than it is when you look at the effect on expenditure. So the percentage in terms of added expenditure is the effects are much less regressive compared to looking at how it affects disposable income. And this is due to the fact that people in the higher income deciles, they actually tend to spend more in terms of energy, in terms of they commute longer distances. So basically, the expenditure effect is less regressive than the income effect. So despite this mixed evidence, it seems that the carbon tax in that case, and in general actually, is regressive. So one way to solve this problem, and therefore to increase public support for the policy, could be just to compensate the regressivity of the tax by doing, for instance, some revenue recycling. So the revenues of the tax will be distributed to citizens. And then it triggers the question of how should those revenues be recycled. On the one hand, one way to do that is just to divide the total amount of revenues and distribute the same amount to each person in the population. The other option would be to do targeted transfers in order to cancel out this regressivity. So by basically giving more money to low-income people who should receive higher transfers, and this should solve the regressivity. So this is exactly the same idea, and basically what Thomas Douane is doing in those simulations is to try to show how a revenue recycling policy that would try to cancel the regressivity of the policy could work with this redistribution. We show that there are, compared to the previous graphs, there are fewer households in the low-income deciles who would be losing from the reform. So basically, he's showing that redistribution of the tax revenues could try to cancel out, to some extent, the regressivity of the carbon tax. However, given that, as we discussed, it's not only a matter of heterogeneity, vertical heterogeneity in carbon footprints, but rural and urban households also differ in how they're going to be affected by the tax. He shows that even after recycling, low-income households would, 1/3 of low-income households would still lose from the policy. So there is this idea that even after recycling the revenues of the tax, it's not easy to make carbon taxes progressive. So this very much, so this is very correlated with the support for the policy, the effect of the tax burden, etc. But I'm not going to expand too much on that, because what I want to tackle now is really so first, let me briefly discuss carbon tax incidence in low and middle income countries. So we know that regardless of whether we are doing flat recycling or more targeted recycling, there will still be losers of the policy, and this is what Thomas Douane is showing. What we have, where the thing on which we have less evidence is actually what happens in low and middle income countries. We have a lot of evidence for European countries and the US, for instance, much less for those countries. And this is because, for starters, those countries tend to have lower emissions per capita. This is something we discussed earlier. And also in those countries, there are limited concerns about regressivity, as poor households tend to spend less on energy traded and formal markets in general. However, this is a growing matter, and it's probably one important area for future research. This is what we're seeing in this Agarwal paper in Uganda, where actually looking at different terciles of the population and different characteristics, so whether the household is a rural or urban household, we see clearly that in the bottom tercile, few people use electricity, for instance, and most people seem to be using biomass that is harder to tax from a carbon taxation perspective. So most of the policies in such countries would be payment for ecosystem services and other types of policy. A potential concern as well with implementing carbon taxation or subsidies on cleaner sources of energies in low and middle income countries is that one policy that could be, if the policy was poorly designed, there could be important substitution from the cleanest source of energy to dirtiest source of energy. And this is what has been observed actually in Uganda, as well as potential damages if people start switching from one type of energy to the other in the wrong direction. Okay. So trying to understand, so what we know, to summarize, is that people tend, that carbon tax seem to be regressive, that it's hard to cancel out the regressivity given the heterogeneity there is in the population. And so actually, De chez Le Prêtre and co-authors, what they've been doing is to discuss, try to understand if other types of climate policies are better supported compared to carbon taxes. So that's what they do. They survey a lot of people in different types of countries, so high income, middle income, and they ask people to about their support for different types of energy policies. And even though this is probably super small if you're sitting in the back, what you should remember from this figure is actually that on average, taxes are always receive a much lower support than subsidies and standards, so command and control policies. So it could be because people fear that those taxes will be regressive, that they fear that they're going to be strongly impacted by the tax. But actually, are those subsidies and standards more progressive than carbon taxes? Well, this is an open question, and it's not super obvious, the answer. So from this De Chellepret paper, we know that citizens tend to favor subsidies and command and control over taxes, and this is quite general. Is it because it's less regressive, or is it because just people have a strong loss aversion? Well, Borenstein and Davis, what they do is that they show that subsidies tend to be more regressive than taxes in the US. And they actually look at who benefits from non-refundable tax credits to encourage households to insulate their home, buy electric vehicles, or install solar panels, so to switching to cleaner technologies, right? And what they show in terms of who receives the tax credits, because these are these are types of policies that require investment from the household, so spending quite a lot of money. They show that the tax credits are received disproportionately by high-income households, and in fact, 60% of the lower income distribution have received only 10% of the credits, while the top quintile, so the top 20% of the income distribution, have received 60% of the tax credits, showing how unequal how regressive this kind of policy can be. And when we look at electric vehicle credits, actually 90% of those credits have been received by people in the top 20% of the income distribution. So this is in part due to the design, the fact that this was a non-refundable tax credit, and a lot of households in the US were actually not liable when it comes to paying taxes. The fact that this relates to a big, to large amounts of money that have to be spent to insulate your home, to buy an electric vehicle. But nevertheless, even though people tend to perceive subsidies are more beneficial for themselves, it's not completely obvious. And as for the tax of standards, in this paper, in the US again, Ari Clevinson asks if standards can be, whether standards would be more or less regressive than carbon taxes. And actually, it's a theoretical reasoning where he argues that energy services are normal goods, so the demand rises with incomes, meaning that the energy expenditure increases with income, right? Whereas energy efficiency is actually quite homogeneous in the population. There is some variation, but much less than for fuel consumption. Therefore, energy taxes, they impose large absolute costs on rich households because they spend a lot on fuel, so they are going to be taxed a lot. Whereas energy efficiency standards, such as forcing people to switch from diesel car to electric cars, actually will have a more negative impact on lower income groups who will face the fee, for instance, and not be able to switch from the dirtier to the cleaner technology. So his whole theoretical argument that is then supported with some data is that energy taxes are expected to be less regressive than standards. And this is something to keep in mind when we think about the incidence of climate policy. So even though these are just examples on whether subsidies and command and controls regulation are more fair, and there could be other examples in which they are less regressive than carbon taxes. It seems that it probably depends on the type of good that would be subsidized, the type of policy design, whether it's a good that costs a lot, has a very high price, or such as electric cars or fresh fruits and vegetables, where more people, or at least there are less pricey and more affordable products in general. And so the perceived fairness of the policy is nevertheless a key ingredient in determining the support for environmental policies. Okay. Okay. So moving on to the last part of the lecture, that is about inequalities in climate change damages. Here, we want to account for climate damages that tend to be an estimation discounted for today of the overall cost projected of future climate change. So it's really trying to understand who will be most affected by this damage. And what the literature suggests in that case is that common climate change shocks that drive or keep people in poverty will be worsened by climate change. So, for instance, an inflation shock can affect people differently based on climate change. And there are indeed 5 channels through which climate change may exacerbate poverty. First, agricultural revenues. So if the impact depends on the share of household working on agriculture, productivity, and income diversification. So obviously, climate change can affect different types of sectors, and the agricultural sector is directly at risk, with varying impact depending on the composition of the household. Labor productivity is also likely to be affected by climate change. And there's this research, like a huge stream of research looking at the effects of climate change on labor productivity, and showing that 1 extra degree of warming could reduce labor productivity by 1 to 3%. So it's more than, it's quite a big effect for people working outdoor or without air conditioners. And those people are likely to be lower income people. Food prices will also be affected. There's also disasters, where we know that in most countries, lower income households tend to be more exposed to flooding than the average of the population. And finally, health concerns, as climate change can increase mortality, notably due to increased heat stress, diseases such as malaria, dengue, etc. And low-income people may have less resources to receive health care. So when it comes to who will suffer the most from the consequences of climate change, there are many papers on that topic. A lot of them are actually at the micro level. So for starters, looking at vertical differences. And for instance, there's this paper by Crows and Reeves where showing that in the US, low-income communities are more likely to live in flood-prone areas. There's actually a lot of research on that, as well as horizontal differences. And for instance, there is this paper showing that in Vietnam, after an oil spill, upstream versus downstream fishermen have been affected differently by the shock. Obviously, an oil spill is not really a climate shock, directly at least, but nevertheless, it's to show this effect and potential horizontal differences of disasters in general. From a macroeconomic perspective, the increase in extreme weather events, such as flooding, hurricanes, etc., should increase inequality, so across countries. And so what we expect is that, a priori, climate change will exacerbate inequalities. So to discuss this matter, let's look at the paper from Gandhi et al. So it's still a working paper from the NBER. And the main research question here is, how does the impact of floods on city vary with cities' past experience of flooding, income level, and adaptation investments? And this directly answering this question can directly inform climate policy and show the importance of investing in adaptation. So for this paper, Gandhi and co-authors, they use global data on about 10,000 cities for a lot of different countries with varying income levels, and look at 4,000 flood events between in the year 2000 to 2022. Sorry, I'm getting tired. So basically, they look at city month-year effects. And the key outcomes here are going to be a proxy for city-level GDP, that is, so for economic activity, that is night lights, which is a standard proxy in the literature, as well as mortality. And they use this kind of proxies mostly because, given the large amount of countries they are looking at, these are indicators that are widely available across countries. So this allows for precision in the outcomes. So interestingly, their motivation is that throughout the years, a lot of countries experience flooding, but actually, and that's here they group countries by income groups. And we see that the share, the percentage of flood is more or less constant over time for each income group. But actually, the percentage of death is much higher and it's growing. So the casualty in lower, middle, and low-income countries. So even though a lot of countries do experience flooding, the disastrous consequences, they are mostly observed in low, middle, and low-income countries. What they do to study this and make sure that it's a causal impact that they are capturing and not something else is to run an event study where basically in this specification I'm showing the explained variable is night lights, and that they explain by the number of flooding, some controls that are at the city, country, month and year level, as well as some fixed effects. And they show in this paper that there are no statistical differences in the evolution of main outcomes between future flooded cities and non-flooded cities in the year prior flooding, suggesting that what they are capturing is indeed the effect of a flood and not the effect of differences in infrastructures, etc. Okay. Or provision, etc. So what they find, so this is the event study analysis of impact on flood on night lights intensity, and here you have the coefficient, is that there is a decrease in night lights, so economic activity, right, because this is the proxy for GDP, right after the flood. And so it's a 4.5 decrease on average for the entire sample of cities. Oops. Meaning a fall in urban activity. And what's more interesting is that they look at the heterogeneity in this effect, and they find that actually in high-income countries, the effect is below the captured effect is below the mean effect. So it's about half of it. Whereas in low-income countries, the effect is 3.5 times larger than the average effect, showing this heterogeneity in the damage associated to climate change. So what they are showing, looking further at this heterogeneity, is that there are less severe impacts for high elevation cities, but only in high-income countries. And this seems to be due to a lack of investment in flood protection infrastructure. So low-income countries seems to be constrained in how they can adapt to climate change and adapt to flooding. And so they suffer the highest climate damage. And looking further at the heterogeneity, the spatial heterogeneity, they find that coastal cities, as expected, are the most impacted cities, and mostly in low-income countries. So the thing to remember here, it's really that this inequality of climate damage associated with flooding. And what they are arguing in this paper is that it provides an evidence in favor of trying to adapt as much as possible, because they show that there are several ways to mitigate the harms from flooding. On the one hand, public policies, such as investing in infrastructures, investing in efficient emergency responses, as well as individuals who also react to the climate shock by either relocating or migrating. And so they measure different types of adaptation. First, a reduction in flood damage, so less death, but also showing that there is evidence of out-migration, but only in high-income countries, so places that are repeatedly flooded. They observe that people are actually moving out those places, even though the effects are relatively small, but only in high-income countries where either people can pay the costs of out-migration or have better prospects in nearby locations, which seems to be the case in high-income countries. So, so those findings really point to the idea of climate justice, given that global warming leads to an increase in the frequency of such events like flooding, and we see that there are clear inequalities in how people can be affected by such damages. The last thing I wanted to mention is whether there is a conflict between reducing global income inequality and stabilizing the climate, so reducing climate change, right? Because given all what we discussed, we could think that perhaps redistributing from high income to low income people would affect global emissions. The key question here, and it's not a trivial question actually, is what is the marginal emission intensity? Is it higher for rich people or low income people? So with one extra unit of income, who is going to emit most is if the emission intensity, the marginal emission intensity is higher for the rich, then preventing them from having this extra monetary unit will actually reduce global emissions. Okay? So there is no conflict in that case between reducing global income inequalities and the climate objectives. On the other hand, if we assume, and this is related to the development story and discussion we had before, that when low-income people get richer, they tend to emit more marginally, then there may be a conflict. And actually, this likely, there is no theoretical or empirical consensus on that, It's a rather challenging question, and the answer, it likely varies both across countries, but also across sectors, depending on the scope of what you're looking at. Okay, so we are almost done, and to conclude on this first lecture on climate change and inequalities, I wanted to remind to you that there are multiple ways in which climate change and inequalities interact. We are here more or less at the frontier of research, which is why there's no clear answer on some things like how would the income Gini versus the GHG Gini evolve if we were to account with more precision for emissions. So the frontier of research here and some potential areas for research are better understanding the inequality in contribution to climate change. In particular, the role of wealth and investment in shaping inequalities in emissions. So that very much relates to this research stream that Chancel has developed, but I'm sure that there are plenty of other researchers. Nevertheless, it's quite niche at the moment, and I think that it's quite crucial to study. Inequalities in climate policy incidents, also to understand better the determinants of horizontal inequality and corrective policies. So trying to better understand the effect of taxes for different types of groups, etc., based on their socioeconomic and socio-demographic characteristics, understanding how a tax can be regressive depending on the amount of initial consumption of the good, but also the elasticity of consumption. Trying to understand better inequality in climate damages, looking at places outside the US from a micro perspective is also a potential area for research. And finally, integrating different abilities to adapt to extreme weather events. So we just discussed out-migration, but there are many other ways to adapt. And earlier we were discussing separability between income and production, consumption and production decisions. So it could be also how households change from one employment sector to another, as well as the risk of stranded assets. So very dramatic, the most dramatic effect of climate change could be to make some places unlivable, and then trying to understand how people cope with this kind of shock that have a very high, that cause a very high damage. Okay, well, that's it. Thank you for being here, and I'll see you next week to talk about international environmental agreements.
Let's go.
I know, but it's going to be
Yeah.
Is it dramatic?
Die Kontakte nicht bekommen. Ich habe jetzt irgendwie was, vielleicht 10 oder so. Das ist jetzt geschafft.
Yeah. No, there's one guy. I wouldn't have expected anything else. Like they weren't just together. It was. Oh my god, they like, well, make you live. Yeah, Johanna said the same thing. I feel like I've run over my wow. I woke up
So we're doing the
yeah. I woke up and I go into the thought of having such Tower of London. Yeah, Tower of London. Basically it's like shit. Oh yeah, we did that. My mom tried to follow them.
Oh, so like, move.
It was good. It was fun. Yeah.
Guys, how was
She was good. She was sick. She ran out at 1 p.m. the next day. Was sick. Was sick.
1 p.m.
Hell yeah, she did Berlin right. Yeah, and then was sick.
What was the name of that suite?
I'm gonna send this to my friends. That is the thing.
Are you fighting today and then fighting together?
Yes.
Yeah,
3:30
Sweet.
8:30.
She's staying until the middle of
8:30.
she's staying.
So I'll text you then.
Yeah, probably. Yeah.
That's great. Are you going to Lidl?
I'm going to London.
No, why?
But you want to do a shopping day?
Yeah,
It's been a week.
yeah, that's true. But like right now, I have like approximately 6 kilograms of pasta at home.
And you have like insane amounts of pasta sauce.
Yeah, exactly. I think I bought too much. And then made me think I bought too much.